drug concentrations deplete from the body in an exponential manner, it is possible to calculate the drug's half-life. The half-life is the time needed for the drug concentration of a drug in the plasma to decrease by 1/2. Note that the value of the half-life is a constant and independent of drug concentrations or the amount of drug in the body. As a result, the lower the plasma concentration of the drug, the smaller the absolute decrease in the amount of drug in the body, but the relative decrease is the same for the same amount of time. We can estimate the half-life by visually inspecting a plot of the Lin values of the plasma drug concentration versus time. Notice that by Lin transforming the concentration values, the y-axis represents decreases in proportions rather than absolute values. As a result, the distance between concentrations that are of equal proportion to each other become the same, regardless that the absolute amount that decreases becomes less and less over time. We can also calculate the half-life from two concentrations that are measured in blood samples that have been collected from an animal using this equation. And finally, we can calculate the half-life from the elimination rate constant using this equation. You might be asking where the value of 0.693 comes from in that equation. It comes from the law of logarithms, which says that the difference between two Lin transformed values is the same as the Lin of the ratio of those values. Since the half-life is the time for concentrations to decrease by 1/2, the ratio of those values will always be 2, regardless of the absolute values of those concentrations. And 0.693 is the value of the natural log of 2.